Let's talk about the synapse. How does information get from one neuron to another? Neurons don't actually touch. Information needs to jump from one neuron to the next across the synapse or synaptic cleft. The synapse is a space between the neurons, about 20 nanometers. Transmission across a synapse is slow. There are many synapses. So we have one postsynaptic neuron with many synapses with it. An impulse moves from the presynaptic to the postsynaptic neuron. The nerve endings of the presynaptic neuron are filled with synaptic vesicles, which contain neurotransmitters. Let's talk about the events at a synapse. First, a nerve impulse arrives at the axon terminal and depolarizes the membrane. Voltage-gated calcium channels open and calcium flows in. Calcium influx triggers synaptic vesicles to release acetylcholine, which is a neurotransmitter, by exocytosis. This requires ATP, so we do have mitochondria in the presynaptic neuron. Neurotransmitters diffuse across the synapse and bind to receptors on the postsynaptic membrane. Ion channels in the receptors open, allowing sodium to flow in, causing depolarization. Cholinesterase, an enzyme, is released to break down the acetylcholine, which stops the stimulation of the postsynaptic neuron. Last, acetylcholine is reabsorbed into the presynaptic neuron. There's two types of synapses. Excitatory causes depolarization of the postsynaptic neuron, in other words, an action potential. It causes sodium channels on the postsynaptic neuron to open, so sodium flows in, making the postsynaptic neuron more likely to fire. Inhibitory synapses cause hyperpolarization of the postsynaptic neuron. This inhibits depolarization. So either potassium ions leak out and/or chloride ions diffuse in. This makes the postsynaptic neuron less likely to fire. Imagine that you're driving down a road with no red lights or stop signs to slow you down. While that may seem like a very exciting idea, it is obviously very dangerous. For traffic to go smoothly, we need stop signs, red lights, and yield signs to make sure no accidents occur. In much the same way, our brain has a mechanism to keep the excitation in check. Information in the brain flows via excitatory neurons. We have to slow down or stop the excitation whenever required. This is known as inhibition. The neurons that perform this function are known as inhibitory neurons, and they make sure our brains function smoothly and accident-free. Epilepsy is a chronic disorder that causes unprovoked recurrent seizures due to inhibitory neuron loss. A seizure is a sudden rush of electrical activity in the brain going unchecked. Effect of synapses on the postsynaptic neuron. The postsynaptic neuron adds together or integrates all of the excitatory and inhibitory inputs it receives and decides whether to fire an action potential. So in this postsynaptic cell, we see that there are 3 excitatory postsynaptic potentials and 1 inhibitory postsynaptic potential. If all 4 were to release their neurotransmitters at the same time, we'll say that these 2 cancel each other out, meaning that there are 2 excitatory postsynaptic potentials remaining, which makes it more likely that there would be an action potential. This is summation, when 2 or more neurons release neurotransmitters at the same time to cause an action potential in the postsynaptic neuron. In this graph, neurons A and B must work together to cause an action potential in neuron D. Alone, they cannot reach threshold. So we see when A and B add together, that is summation, they reach threshold, and neuron D fires. Note that both A and B are excitatory synapses, and C is an inhibitory synapse.